I wanted to share you some results of my PhD study, what I made in Mexico. And the topic of my study is the tepetate fragipan. So to start with fragipan, let me remind you some basic parts of its definition. But it's subsurface non-cemented horizon, which is presented in blocks of polygonal prisms divided by cracks, and the pieces of fragipan submerged in water slakes in less than 10 minutes. And then they starting to talk about the fragipan, we want to understand how it was formed. And the history of fragipan study started almost a century ago, and it was first defined as silica hard pan layer, and then it was assumed that it was formed by cementation by silica and iron oxides, but it's also supposed that may be other horizons that were formed by pedogenic processes, and the agent of compaction was clay, and it was a result of physical compaction. But then they were divided like fragipans and duripans, and duripans were the one what was cemented by silica. And since that, there were many other hypotheses of fragipan formation, since silica wasn't applicable anymore. And there were a hypothesis of formation by expandable minerals, and they were also intends to explain it by the desiccation process. There were also some hypotheses that refers to local climatic conditions, as the formation on the relict of permafrost, or formation provoked by the weight of the glacier itself. So this hypothesis would only work in the conditions where the glacial affected the formation of fragipan. So there are some other hypotheses, for example, the hydroconsolidation, which explains the formation of fragipan as a process of reorganization of clay particles, which connect bigger grain sand and silt in the matrix of the horizon, and therefore they compact the horizon in the process of desiccation or repeated desiccation. And then let's move to the another part of my topic. It's the tepetate. Tepetate is a term that is in use in Mexico, and this term explains or refers to these dense horizons that are exposed to the surface by erosion, and they are morphologically presented as polygonal prisms divided by cracks, and they are very dense, and they're used as construction material, for example, as they are in the natural look. And then these horizons were also tried to be explained by the formation of silica, and then there were also another hypothesis which refer to the formation by clay minerals. So let's move to our study place, and it's located in Mexico in the Trans-Mexican Volcanic Belt in the state of Tlaxcala. And here you can see in other areas the fragipan the tepetate is presented in Mexico, and here we work only in this area. And the tepetate horizons are presented here in huge gullies, and they look like these prismatic columns divided by cracks, and they are presented in these profiles interlayered with paleosols. Let me show you again the location of the profile. It is located in a huge gully formed most probably by the human impact in previous times. And this profile is located in this next to the Tlalpan settlement. That's why this gully is called Tlalpan, and it's about 15 meters high. And you can see these tepetate horizons here. And this gully is growing each year because these gradually increase with with rainy season each year. And then let me show you the profile what we studied. We took for the study exactly the profile which was under study for 15 years ago by another scientist from Germany, and they identified this horizon, this tepetate horizon, as cemented by silica. But what they did first, they put the piece of this compacted horizon to the water, and it's lake in less than 2 minutes. So we can't assume that it was cemented by silica. And let me show you in more details the profile. So this is the tepetate horizon, which is inside of the Luvisol profile. And below it, there is a vertisol, paleovertisol, which was dated as 33,000 years. And in previous studies of Dr. Sergei Sedov and colleagues. And below it, there are two other tepetate horizons. On the top of this Luvisol, we have another paleosol, and on the top we have modern soil with many artifacts on its surface. And let's see from the inside to this tepetate horizon. As we can see from the computed tomography images, we see that this horizon has homogenic structure and inside of it, and its pore space is mostly presented by texture pores, which are thin and small and non-connected, and they are distributed homogeneously. This distribution favors us to think that it was formed by hydroconsolidation, this porosity, since it's the description of it consists with descriptions of fragipans in other studies. And for example, to compare, this is the image of the pore space in this superior horizon, which is located on the top of this tepetate. And it also has some bigger pores, as you can see here. And these bigger pores, as we can see from micromorphology, are filled with elevated clay. And these infillings occupy almost 80% of these big pores. So we think that this tepetate horizon was formed in two steps. And first it was a compaction and consolidation. And then it was also compacted by the clay infillings, since they also occupied the pore space in this horizon. And then I want to show you the pore space, how it looks in another horizons. For example, this is an image of pore space obtained from the A horizon of the modern soil. We see biogenic channels here. And this is the pore space of the paleovertisol, and we see these slick inside surfaces in the pore space. And these are two different tepetate horizons, and we see that they are very similar in the pore space distribution. To show you some more micromorphology, so we see again these biogenic channels in the upper horizon of the modern soil. In the first paleosoil, which is below this modern soil, we see initiation of formation of wedged aggregates in this matrix, and then we see these iron concretions and accumulation in the horizon, which is on top of tepetate horizon. And this is the tepetate horizon, and this is another tepetate horizon. Again, they look very similar. They have this homogeneous texture, and they show both these huge infillings of elevated clay in here. And this is the image of the paleovertisol, which was also in the profile, just to show you how they differ in all these horizons. And then I want you to pay attention also in this iron oxide accumulation. Since the in 2020 there was an article that suggested redefine the fragipan the fragipan definition in the field, and it says that it's important to find the redexomorphic features on the horizon which is on the top of the tepetate horizon. So by this we comply also this requirement for the tepetate to classify it as fragipan. And therefore, they conclude that tepetate of Tlalpanguli are the fragipans, and they were developed in the Louis profile, and the compaction was achieved in 2 steps. And the tepetate of Tlalpanguli have been formed in Pleistocene environments, and therefore they are an important source of information for paleoreconstructions in central Mexico. So that was all, and thank you very much. I'm waiting for your questions.
Any question for Lilit?
The silica hypothesis. So it's definitely not a durapan in which there is abundant silica, but the cementation by silica, if it exists, would it be more like glue at the grain contacts, a very thin, minute adhesive, rather than an engulfment of silica?
Thank you for this question. Yes, we were trying to find these signs of these infillings, but as you can see from the images of micromorphological images, we didn't find these amorphous silica bonding what you're talking about. And also, this is about reversible cementation, so by clay. So we're talking about the compaction which is made by clay, and then we see how it slakes very fast in the water. In less than 2 minutes, it's lost its structure. Would it be possible with this formation of silica, what you're talking about, to be cemented in such way?
Thank you.
Dr. Sedor?
Maybe I could add something to the response of Lilit as co-author of this presentation. Besides this micromorphological study, there were numerous other studies, quite detailed, including electron microscopy, high resolution electron microscopy with microanalysis, all for search of this amorphous silica, which was and is until now the basic hypothesis, the dominant hypothesis for origin of tepetate. Few people share the idea that it is clay and fragipan. Mostly it is still accepted that it is silica. But no evidences of silica, despite all these efforts, amorphous silica as cementing agent for tepetate were found until now. So the followers of this silica hypothesis now say that silica is somehow related to clay, mostly to smectitic clay, and together they form the cement of tepetate, but it is invisible by analytical methods. Of course, there are normal chemical studies, extraction of amorphous silica with alkaline solutions, but this is not they show quite high values of amorphous silica, but this is not an argument in favor of silica cementation hypothesis, because we have a lot of opaline phytoliths in these horizons, which are also made up of amorphous silica. Thank you, Norma.
Thank you, Sergey. Any other questions for Lilit? Well, we have time. Thank you very much, Lilit. And thank you very much.
Cheese.
Our next